Welcome to clickmyproject.com. Let us see the process called remote sensing image segmentation by combining spectral and texture features. Let us see the abstract for the process remote sensing image segmentation by combining spectral and texture features. Here, remote sensing image is taken as the input and converted into the grayscale image. Then the grayscale image is filtered by using Laplacian of Gaussian filters. After that, the features are enhanced by using local spectral histogram. Then we are clustering the image using k-mean clustering. Moreover, the clustered image is segmented by using RGB colors. The SVD is calculated for error estimation and plot in the graph. And finally, the overall performance is good. First, the input image is filtered after taking grayscale by Laplacian of Gaussian filters. Then the image is enhanced by histogram equalization. Then k-mean clustering algorithm was used for clustering the image. Remote sensing images are segmented based on spectral and texture features. The SVD is calculated for error estimation based on the image. The advantage of this process is this method is effective and provides better accuracy. This process gives high resolution and moreover it will save time and reduce a delay problem. In this process, for clustering the image, we are using k-mean clustering. Here, clustering means it is a classification of objects into different groups, or more precisely, the partitioning of a data set into subsets so that the data in each subset share some common trait, often according to some defined distance measure. The k-means algorithm is an algorithm to cluster n objects based on attributes into k partitions where k is less than n. It is similar to the expectation maximization algorithm for mixtures of Gaussians in that they both attempt to find the centers of natural clusters in the data. It assumes that the object attributes form a vector space. And finally, the remote sensing image is segmented and it is useful in many of the processes. The remote sensing image is segmented based on RGB colors. The SVD is calculated for error estimation and then we plot the graph. Moreover, the overall performance is good in this process. In this flowchart, a remote sensing images are taken as input to the system and save the images into the computer. After that, the input image is converted into the grayscale image, and in order to improve the quality of the images, we normally employ some filtering operations. Then in the filtered image, the grayscale image is filtered by using Laplacian of Gaussian filters. To specify the histogram, there are certain set of filters, but in this process we use Laplacian of Gaussian filters because it is used for smoothing the image and for the removal of noise. Then the images are enhanced by using local spectral histogram. The histogram is taken for all input bands because it provides effective feature for both spectral and texture information for remote sensing images. Then the enhanced image is clustered. K-mean clustering algorithm was used for clustering the image. Simply speaking, K-mean clustering is used to classify or to group the objects based on attributes or features into k number of groups. K is a positive integer number. The grouping is done by minimizing the sum of squares of distances between data and the corresponding cluster centroid. Then in the segmented image segmentation is typically used to locate objects and boundaries in images. The clustered image is then segmented based on the spectral and texture features. The images of segmented boundaries with RGB color. Finally is the performance. In that the SVD is calculated for error estimation based on the size of the image. SVD means singular value decomposition. The SVD is extensively used in image processing for plotting the graph, and then the overall performance is good in this process. Let us discuss the running procedure for the process called remote sensing image segmentation by combining spectral and texture features. In this process, the main code is in remote.m. Now I am going to run this file. The file is running. This is the output screen for this process. First, we are loading the image. From the dataset. Here the images are in JPG form. We can load any image. Then the input image is converted into gray image. After that, filtering operations take place for this image by taking Laplacian of Gaussian filter. Then the image is enhanced by using local spectral histogram. Next, clustering process takes place for this image by taking k-mean clustering. This is the clustered image. After that, the image is segmented in RGB colors. This is the segmented image based on RGB colors. Then the performance. In the performance, the accuracy is 65%. This is the good performance because for the segmented process the accuracy 65% is better. Then plotting the graph by using SVD, which means singular value decomposition. It is based on error estimation. Here the error is too low, which is the advantage for this process.